So the radius of an atom and the radius of a nucleus are both very, very small. And today we're going to look at representing small numbers using something called standard form and how we can compare two small numbers using standard form. So firstly, you might be more familiar with using standard form to look at very big numbers. So for example, if we look at this number here, 5 times 10 to the 3. So you can tell this is standard form because it's using a power of 10 and that power is a positive power. So we know essentially that the decimal place is going to move to the right, and that number that we are looking at there is 1, 2, 3 is 5,000. So the decimal place has moved 3 places to the right. Looking at a small number, it looks very similar, but we've got a negative power here, and this means that the decimal place is going to move 3 to the left. So if you've got number there, originally the decimal place was there, so the decimal place now goes 1, 2, 3, and the number we are now looking at, this is 0.005, so it is essentially looking a lot smaller than this number here. So let us look now at the radius of an atom. So the radius of an atom in standard form is 1 times 10 to the minus 10 meters. What does that actually mean? What does that actually look like if you were to write it out? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots there. That is what the number looks like when written out in full. So you can see that actually it is a lot more convenient to be writing these numbers out in standard form. So that is the size, the radius of an atom. Now, if we look at the radius of a nucleus, so that is 1 times 10 to the minus 14. So looking at that, a common mistake that students make is they think that this is actually going to be bigger because that power is bigger. Actually, all that power means is that that decimal place is moving further to the left and that number's actually smaller. So again, same starting place as next time, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You can see quite quickly that number is indeed a lot smaller. But how much smaller? We can use standard form to make to compare two very small numbers much easier. So when we're comparing how much bigger one thing is to another, essentially if we've got the nucleus, the radius of the nucleus, by how much do we have to times that by to get to the radius of the atom? What we can do is divide both sides by the diameter of the radius of the nucleus. And so what we have, the atom was 1 times 10 to the minus 10. Divide by 1 times by 10 to the minus 14. That's the size of the nucleus, the radius of the nucleus. And when you are dividing one standard form number by the other, actually all you need to look at is these powers. And if you're dividing one by the other, you take one power away from the other. So that's going to be minus 10 minus minus 14, which is equal to 4. So the answer to that is 1 times 10 to the 4, which is equal to 10,000. So we know that the atom is 10,000 times bigger than the nucleus.